Good morning, everybody. Hello and welcome to a further learning session with the topic ClimaECO, room climate control with ventilation and air quality. My name is Thorsten Reibel from the Building Academy Smart Buildings. Yeah, and I'm together with Jürgen Schilder, and we will share this training session today. Yeah, we will have around 30 minutes for this content today, and it will be a more practical view into the topic room climate control with ventilation air quality. On Tuesday this week, we did already the more theoretical considerations, the products, solution, and so on. And we will have today more a practical demonstration, also a deeper look into the ETS programming. And this will be then done by Jürgen. And as always, we record this session and will publish then later this content. And of course, you get also this feedback email with the presentation and the video link. Practical learning session. Let's have a small summary of the content we are doing today and the system behind. Of course, we talk about ABB KNX, and here's a ClimaECO range, which defines our HVAC solutions, all the products behind, all the solutions. And ClimaECO is a holistic heating, ventilation, air conditioning, HVAC automation solution based on ABB KNX. So not only room control, but also the distribution part with the heating, cooling, circuit controller, the interface to the boiler, the chiller, the source of the hot and cold water is possible, including automation, including interfacing to BACnet, all these components we have here in our ClimaECO range. And you see here the summary of some of the products, not only. And today, of course, we talk about the ventilation part. We did a lot of sessions, learning sessions around this topic. More will come, but you find everything here in our training and qualification database. So allow me to turn off my video. Good. Yeah, you see here the products as products itself. So with an image, and you see a lot of room temperature controller, operating elements, air quality sensor, and so on. And the products we were talking already on Tuesday and now today in a more practical view are the room temperature controller, including CO2 and humidity sensing, but also control. The same is possible with the air quality sensor, but no display, no operating element. And of course, the blower actuator, the actuator to run the blower. Yeah, you see here in principle the constellation. So any of these sensors you would have in your solution with ventilation, all three can do more or less the same in terms of control and measuring the values. Of course, you can integrate also a presence detector, so that special situation regarding ventilation take only place if somebody's in the room. Otherwise, you go to standby mode, for example. Here's a blower Actuator FCL. Yeah, and there are also other components can do this job, controlling fans. For example, also the fan coil controller. There's also the option to connect, of course, a valve. An option would be also to use a shutter actuator to open any windows for kind of natural ventilation. So you can automate this as well. If you motorized electrical window, this is also possible to do with shutter actuator. So it's possible to integrate more components, even analog actuator instead of stepwise control. I come to this in the next slide. You can say, okay, I would like to have the continuous control of a fan via 0 to 10 volt signal, for example. Then also an analog actuator could be involved. Yeah, you see here a typical situation. We were talking about this principle of CO2 and humidity influence to the room climate on Tuesday already. Here is a recording of a CO2 value and the humidity, the relative humidity in a working room. It's done via the control touch. You can quite good record record value. There's a data logger behind with a good resolution. And you see the increasement of the CO2 level. And then in this case, a window was opened, so simple natural ventilation, and then the value drops. The same more or less for the humidity, the relative humidity. It's increasing as well. And then after ventilation, it's going down again. 2 slides left from my side to just summarize the components we are talking about today. So the air quality sensor you see here on the left, the component is 2 LEDs showing in different colors the CO2 or relative humidity level. So it's a kind of warning light. Green is okay. If it's getting red, then it's too much for sure. Then you have to take action, if not done automatically. Measurement and also control is possible. So there are real 3 independent controllers also for the room temperature inside available to do the job. Yeah, so with these components you can then make this control of air quality in terms of temperature, humidity and also CO2. And typically you will then control any 3-stage fan, single, 2 or 3-stage, can also have also 1 level only. It's also possible with switch actuators if you want. Yeah. If you would like to have a PI control coming from this controller, for example, then it can be transferred in the blower actuator FCL as also to stepwise control. Yeah. Of course, with the other components, you can display also the values. You see here on top, relative humidity on the upper right side, and on the lower right side, CO2 concentration. The same here at that ABB Tenton. On the upper right side, there's in change the relative humidity displayed with the CO2 concentration. So in principle, all these 3 components are in terms of control of these 3 different values, CO2, temperature, and relative humidity the same. Of course, different design and different way of operation. Here, no operation. So, and the blower actuator, the device, we were talking about this already on Tuesday. In principle, a component with relays inside. Yeah, controlling fans and blowers as possible, but also a fourth relay to turn on any other load. Could be also light, but in terms of air quality control, it could be a main switch of the fan, it could be also a damper or a valve, whatever, and can be also integrated. We have components with 1 output or 1 channel, or with 2 channels. And it's possible also here in this component with 2 channels, for example, to use not used fan relays for individual relay control of any other loads. Also light control could be possible. Yeah. And the way of control of the 3 relays, it's a bit tricky, not tricky, but different from a normal switch actuator option, because we can have the so-called changeover or step switch control. What does it mean, changeover? Then I do not turn for controlling the second stage, the second relay in addition on, but I turn off first of all the first relay from the step 1, and then a bit later I close the second relay. So there are never more than 1 relay closed, and step switch means I close 1 relay after another. Depends on the behavior of the fan. You have to take care of this, depends on the hardware you have. Yeah, and of course this component receives always the control value from the controller. Good. So short summary of what we have done in principle already on Tuesday. I hand over now to Jürgen. He will come to the practical demonstration of the solutions, and I hand over to Jürgen now.
Hello and welcome. Jürgen Schilder is speaking. Thank you, Thorsten, for the introduction. Today I will show you a practical example of fan control with an air quality sensor and the blower actuator. This includes the parameter settings in the ETS, the linking of the group addresses between the ABB control element Tenton and the blower actuator FCLS, and a practical demonstration. With another camera, I have here separate IP camera, you can observe the behavior of the blower here on this training board and the switching of the fan speeds. But at first I would like to start with an overview of ventilation and air quality, and then I come to this practical exercise. So here we have a typical room like in school or meeting room, some physical values like temperature, humidity, CO2, air pressure, and depending on the people, the air quality becomes more bad because the human beings exhaust some CO2 and humidity. A pleasant room climate is ensured now with KNX. For this, we need at first a blower actuator and of course a blower who blows the air out and fresh air inside the room. So one thing is we need fresh air and we have to blow out the CO2. So this is very important. So for this, we need additionally here a, let me say, air quality sensor. The air quality sensor measures the room temperature, the CO2, and the humidity, and send this value, for example, on KNX to make it visible on a display on a touch panel. Additionally, the devices have controller inside, a controller for room temperature control, for CO2 and humidity. And depending if the room is occupied or not, or via time switch, the controller sends these control values, one for CO2, one for humidity, to the blower actuator. And the blower actuator can be in the so-called automatic mode. Automatic mode means he is listening to these control values and the fan goes here in the different speeds, 1, 2 or 3. This is so-called automatic mode. Another mode is the direct operation. It means the user here in the room can press a button and change direct or manually the fan speed. So in this direct mode, the blower actuator is not listening to the control value. He's listening here to the manual commands for up and down, for example, the speed of the fan. And via one button or via time function, the actuator can go back automatically to this automatic mode after a direct operation. Good, then let's do a practical exercise. We want to do both the direct operation and the automatic control. For this, we use here our ABB Tenton. The Tenton has advantage. We can also here show the CO2 concentration and also the relative humidity. So it is here displayed, and via maybe a short time difference, every 10 seconds or every 20 seconds, it changes between the humidity and the CO2 concentration. So inside there are the sensors to detect the CO2 concentration and the relative humidity. The user can change the fan speed manually via this rocker here. On the left side, go up with the fan speed, and on the right side, go down from 3, 2, 1. And if you press again, then the fan stops. This is so-called direct operation. And via the first rocker here on the left button, we can activate the automatic control and on the right side deactivate. It means when we activate it, that the information goes to the blower actuator. The blower actuator knows, okay, I have now to listen to the control value of CO2 or relative humidity. And if the end user presses here one button, like up and down, he sends the information automatic stop, and then the device, our blower actuator, listening to this command for fan speed up and down. This is exactly the exercise we want to do now. For this, I share now my desktop and show you the parameter settings in the ATS. So now you can see the ATS. I have prepared a project, so we don't need to add again the devices. I would like to start at first at our air quality sensor because he measures the CO2 concentration, the relative humidity, and he calculates the control value. So here on my training board, later you will see it with the camera, I have the ABB Tenton SBCU10 with HVAC function and CO2 and relative humidity. So at first I go to the device settings, to the general parameters, and I can activate here the function display actual temperature on the display, yes, if I want. And for example, also here the display of the CO2 value. Oh, let me disconnect. Yeah, I want to see also the display on the display the CO2 value, and I want to see the relative humidity. So this is an additional feature which allows me to see really the CO2 concentration and relative humidity here on the display of the Tenton. So, and the changing here, the display changing interval is here, for example, 10 seconds. You can reduce it up to 5 seconds, and then you will see at first the CO2 concentration, and 5 seconds later the relative humidity, and then again the CO2 concentration. So it will change every 5 seconds here in the display. So, and then we go in the next step to the CO2 sensor. Default, it is inactive. We activate now the CO2 sensor. We can make here at first some correction of the CO2, but it's not really important. Here we can change the behavior, for example, when the value should change. This is a value according to the KNX data point type 99008 parts per million. Maybe if the value changed every 10 ppm, 20, 50, 100, what do you want? I use here the default value, 20 ppm. Or send also the value cyclically. Yes, every 10 minutes, every minute, or inactive. What do you prefer? I think it makes sense to send it every 10 minutes. So we keep also here the standard parameters. So this is only the value as a 2-byte information on KNX. So in the next parameter window, we can activate now the controller. We can use here a single stage, a 2-stage, or 3-stage. Yeah, these settings can be used if we want to control a switch actuator. If a blower is connected to a switch actuator, then we can use here this 1-bit information via single stage, 2-bit, or 3-stage. But we want to control our blower actuator via so-called control value between 0 and 100%. So we set here control value as percent, or if you want, you get it also as a byte. But now best solution is here to use the percent. And here again, the sending behavior, the value changes when it changes every percent, 2%, 3%, well, let me say 2% is okay, and cyclically every 10 minutes. Good, then we come to the next window, which is our PI controller. Here you can change the set point, like for example, typically 1150 parts per million, or maybe less, 1000, like I use here in my exercise, to 1000 ppm. The P component, here about 200 parts per million, or the recharge time, yeah, a little bit strange name. Here this is the I component in minutes. The same P and here the I components. And the maximum control value, minimum control value between 0 and 100% is okay. Good, so far the settings of the CO2 sensor. Then we go to the relative humidity sensor. So here again, we activate the sensor. Then we can make here, for example, a correction, and we can set here again the sending behavior of this value. When it changes every percent or 2% of the relative humidity, like here 2%, and cyclically every 10 minutes. So what we now also can set is here the data point type of this value. So in the KNX association, or the KNX association has specified a 2-byte value from the data point type 9007 for this relative humidity. Yeah, in principle, it's a value between 0 and 100%. So we can also change it here to another one, to the standard data point type 5001, which is between 0 and 100%. Like we have it, for example, in the brightness value of a dimmer. So we have also 0 to 100%. But we want to do it in the best way. We say, okay, we use the standard data point type as a 2-byte value. Good, and then again to the controller, similar the same settings like in our CO2 sensor. We set here the PI controller, then we can also set here the percent. Yes, it's okay. In case of change 2% the control value, yes, it's fine. And this should send the control value every 10 minutes. Then we come to the next menu, which is our PI controller. And the PI controller, we can set here the set point of 30%, the P component in also relative percent, and the I component in minutes, like 50 minutes. Okay, so far are the settings. So with the first rocker, we want to switch on and off our automatic mode. So we can use here the function to button, and common parameter, we want to switch the automatic mode on the left side on. So he must send the value 1. And on the right side, we want to switch off the automatic mode. So we have to send on the right side of the rocker with the second button the value off. Additionally, we can use here the LED to show here the status of the automatic mode, but I skip now here the LEDs. So with the second rocker, our button pair 3 and 4, I want to switch the fan speed up and down. So I can also use here the 2-button switching. So on the left side, I want to switch the fan speed up. Then I have to send a value 1. So the left button, the button number 3, must send a 1, the logical 1 on, and on the right side are off. And with a off, we can switch the fan speed down, left up, right down. Okay, so far the parameter settings of the air quality sensor. Then let's go to the fan coil, to the blower actuator. Blower actuator, we have some general parameters, and the enable of the outputs. Like here, my output A, this is the blower actuator with 2 independent fans. So the output A, we use it for our standard fan. The output B is our additional switch relay for main switch of the blower, for example. We don't use it. And the second independent fan output can be used for a fan or also as a switch actuator, also possible. So, okay, we have only one fan on our output A. So we come here to the importance parameter. At first, it's a multi-level fan. Yes, of course, we want to use all 3 speeds. No limitations, only two fan speeds. And here, this is the important parameter about the operating mode. It's a changeover or step switch. This is what you have to read in the manual of the motor. So please have a look in the technical data sheet, how the motor is operated according to changeover or step switch. So direction on bus voltage failure, bus voltage recovery, for example, or if you want to use a forced operation, we can activate it. The automatic operation, yes, automatic means he is listening to the control value sent by our air quality sensor. And additionally, we want to use also the direct operation. So via the second rocker, we want to switch up and down the fan speed. And if you want to use a startup or run-on behavior, you can also enable it here. So then we come to the next submenu here, status messages. We have different status messages with 1-bit information. So we get then per fan speed a 1-bit status object, or we can also have here a 1-byte object. In the 1 byte, between 0 and 255, we have the speed. So if the byte has the value 3, then we are in the fan speed 3. Fan speed 1, the byte has the value 1. This is, I think, here enough for my example. We can also enable here a status byte mode with some more information, if the automatic mode is active or not, fan speed and some more information. The status, if the fan is on or off, and the status of the automatic. This makes sense. Then the actuator gives back the status information if it's in automatic mode or in the direct operation. For example, to show it on the LEDs of our air quality sensor. So then we come to the automatic control. At first here we can set the automatic mode if it's activated with the value 1 or 0. Here typical default is 1, which makes if the bit has the information 1, then he goes in automatic mode, which is okay. And then we can set here the threshold for switching the different fan speeds. At the moment here, it means the fan is off between 0 and 9%, and if there's a control value 10%, then he goes in fan speed number 1. The same here for fan speed number 2, when it's larger than 30%, and a control value of 70% or higher means go in the fan speed number 3. So additionally, we can set here a hysteresis for switching between the fan speeds here of plus minus, for example, here 5%. And a minimum dwell period in a fan speed is possible. So this is also a very important parameter. Number of control value inputs, only 1 or 2. Here in my example, we have an air quality sensor. He sent a control value for relative humidity and CO2. That's why I have to enable here 2 value inputs. And then I can decide, should the blower actuator use the largest value or switch via communication object between this control value or the other one. I think it's good to say largest value, because then he uses always the largest value of the relative humidity control value or the CO2. And additionally, we can monitor this control value, and we can also enable here some limitations. So then we come to the direct operation. Direct operation means that the end user via a rocker can change manually the fan speed. He can do it via 1-bit objects, but this is not what we want. We want to switch between one rocker up and down the fan speed. Left up and right down. So we have only to activate here the fan speed up down button. Good. These are so far the parameter settings. And when we have a look here on the group objects, then you will see we get here the object fan speed up and down. This is the 1-bit object with the value 1 up, with the value 0 down. Here we get the byte, which gives us the information of the fan speed between 0 and maximum the value 3. The automatic to switch in the automatic mode, yes or no. The status for the indication on the status LED, if it's automatic mode or the direct operation. And here he receives the control value A. This is, for example, my CO2 control value, and my control value B is, for example, the relative humidity control value. Good, these are the group objects we have now to link with our air quality sensor. And when we look on the air quality sensor, then you see, for example, here on the object number 86, this is our CO2 value in parts per million in 2 bytes. and on the control value is here on the object number 90 between 0 and 100%. And the same for the humidity. On the object number 95, we have the relative humidity, and according to the data point type 9007 as 2 byte. And the control value is here on the object number 99. So now we have to link these group addresses between the blower actuator and our air quality sensor. And I show this on the slide, so I go now back, just a second. So on this slide, you can see the linking of the group addresses. It's an example which fits here to my exercise. Like here with the first rocker on the left, on the right side, we can switch between the automatic mode. So we need a group address linking from this object rocker 1, button S1, S2 to fan automatic. The value 1, he goes in automatic mode. Value 0, he goes in the direct mode. For showing the status of the automatic mode, we can use another group address and link it to the status LEDs. So for switching the fan speed here up and down, we need another group address linking to our rocker number 2, button S3, S4, left side on, right side off, link it here to the object fan speed up and down. The control value of CO2, we link it here to our control value A, and additionally we send here the value as 2 byte on the bus to make it visible here in our group monitor or on a touch panel. And similar, it is here for the control value for the relative humidity, link it here to the control value B and send also here the value as 2 byte on the bus. So the information, status fan speed, our 2 byte value, is also group address linked, so we see it now in our group monitor. Additionally, we can link more group addresses for the status of the fan or 1-bit information for fan speed number 1, 2, or 3. Good, so far the linking of the group addresses. I go now back to the ETS and show you now the practical exercise. I start now the group monitor that you can see the telegrams. So here I have again the picture of the exercise. The first rocker we switch between automatic mode and direct. The second rocker we switch the fan speed. But at the moment we have a small problem to simulate the CO2 concentration and the humidity to see the different control values between 0 and 100%. So I found here a solution, or I do it in this way. I have here an analog actuator, and with an analog actuator, I have potties to simulate here a CO2 concentration between 700 and 1800 ppm. That's what I simulate here with another device and send the value to KNX to the ABB Tenton. The ABB Tenton, we have a parameter that he can listen to the measured values with his sensor, or we can say listen to an external value. So that's what exactly I have set here in the parameter. I have here set external measured value active and use only an external value. So my Tenton here do not use his internal sensor. He's listening to this value which I have simulated here via analog actor. And the same for the humidity. So via a second potty, I can simulate here humidity between 30 and 100%. That is also send it here to my ABB Tenton, and he used this value to control then the second control value for the humidity. Good, and the thresholds I have set here in the ETS for fan speed number 1, when the control value is larger than 1%, fan speed 2, 30, fan speed 3, 70%. So and then let's start. I show it you now in real. Let's check the camera. Yes, the camera is okay. So then I press here the button, start the recording. So at the moment you can see we have here 700 ppm and 30% of relative humidity. I change now via a potty the relative humidity. You can see 920, 1000. At the moment I have here more than 1000 parts per million. You see he goes in the fan speed number 1. The LED is here on. And you can see additional here the information on the group monitor. I have here my external value. This is what I have simulated. And now the ABB Tenton said, okay, more than 1000 ppm. He starts with a control value of 2%. 2% means go in fan speed number 1. When I now change here again the CO2 concentration, you see here at the moment he goes to 1200. 13, 1360, he goes in the fan speed number 3, with a control value of 37, 48%, 55. Again, the CO2 concentration is rising, and at the moment here I have more than 70%, and then you will see he goes in the fan speed number 3 with 73%, and my status byte here gives back the information he's in the fan speed number 3. Good, okay, then I go back, simulate, and say okay, back to my 700 ppm. You see the relay, the output fan stops. I start now rising the relative air humidity, 37, 43. So we see here 45% relative humidity. He calculates a control value of 12%, and then he goes in the fan speed number 1. So okay, then we have here more than 50% relative humidity. For example, you see it also on a display, 58%. Here's the fan speed number 2. You see a control value of 45%. And when I say, okay, here full relative humidity, 84 or up to 99%, then you see here fan speed number 3. So now when I rise also the CO2 concentration to the maximum value, like for example 1790, we are still at the same level, number 3, but then I reduce now my relative humidity, like for example here to 0, but we are still at the level number 3 because I said use the largest control value, and now at the moment the largest control value is here the CO2 concentration with 80%. The humidity is 0, but here the CO2 is still 80%. So the blower actuator listens always to the largest control value. Good, so far this is the automatic mode, but the end user wants to also operate the fan manually or the blower. So then we can use here these 2 buttons up and down. So for example, when we press here on the button up, first let me delete here the recording. So when I click here on the button up, then you will see what happens. At first, he sent the command increase value 1 to the blower actuator, and you will see that the automatic mode is also now disabled. So the ABB Tenton knows, okay, we want to operate a fan direct. Then he sent the command, go fan speed 1, go up, and stop this automatic mode blower actuator. And then the blower actuator is only listening here to this button. Now, like here, the left side up, and on the right side, go down. So, but what happens if my CO2 concentration is now rising? Let me say, for example, up to 1780, and we have here full humidity. Nothing happens because the blower knows we are now in the direct operation, and then he's not listening to the control value. You see here full control value 100%, but now we are here in the direct operation, and then he is not listening to these control values. Only if you switch back here to the automatic mode with the first rocker here, you can do it here manually, or for example also via time switch. After an hour, go back to the automatic mode, and then you will see that the blower actuator now listening to the largest control value and goes to the fan speed number 3. Good, so far a practical demonstration about room climate control with a blower actuator and an air quality sensor, the direct operation and the automatic control. I would like to say thank you for your participation, and I hand back now to Thorsten.
Thank you, Jürgen, for this mainly practical demonstration. I think it's not a miracle what we are doing here. It's standard assignment of group addresses. Okay, we have 3 controller in our components. Bit tricky or a bit more, let me say, powerful is this evaluation of the highest control value, as we have seen, that you always control according to the most critical situation, either relative humidity or CO2 concentration. Yeah, of course, you can also adapt these solutions. We were talking about analog actuator just to control and continuous control to control continuously a fan, for example. So all these things are possible. And with more logic, for example, in the building automation controller here, of course, you can create even more solutions here. I go then to my final slides. You know you find everything around the product on our homepage, abb.com/knx. Then we have our training material and our training and qualification database. Everything is stored there. Also this content will come in the next days. Video plus a presentation, and also the videos are available on our YouTube channel. So the software repository, I would like to mention this again. This Excel sheet on our homepage containing, according to regarding KNX, all ETS applications from the oldest products we had in the past up to the current ones. Of course, always this file will be updated if we have new product, if you have a new application. So it's easy to find actual but also old applications for ETS, for the ETS for any ABB product. So it's mainly related to KNX, but for Welcome IP and Free at Home, you have at least current firmware versions available. There are no applications, of course, for the products, but for firmware, you get also support here. It's available under abb.com/knx. Additional materials, download for KNX, and then software repository is an Excel sheet you can download, and then you have it on your PC as well. And as mentioned, always updated from ABB. So what happens next? First of all, we would like to come to the Light and Building Fair, which will, I wouldn't say 100%, but I'm pretty sure that it will take place now in October, 2nd to the 6th of October, the way we did it already many years in the past. And ABB, of course, has a big booth now on the new hall number 12, Bojega and ABB booth. So it's a classical fair, but Light and Building will also take place as a kind of virtual event in addition, called Light and Building Digital Extension. Please have a look on the homepage. I'm not quite sure what's happening there, but there will be a lot of, let me say, digital content then and digital activities. Let's have a look what's going on there. It will go also a bit longer than the 6th of October. Some more days it will be available. So from our side, we continue with the topic HVAC. We did already a lot in the last year, but we think it's worth to talk about the application controller ACS a bit more. This powerful component for automation, for interfacing in our ClimaECO range. So again, an online learning session on the 10th of May and a practical learning session, and you can do a lot of practical things with the application controller. Think about the web UI. The application in the ETS is also very powerful. So this will be then the content on the 12th of May. And we would like to continue then in the beginning of June with the ETS 6 in introduction, and in practice we would like to show also here something we do it with a webinar, so a bit longer than but in one session only. Good. No questions at the moment, then we say thank you for your participation and hope to see you the next time. We will send the invitation, and of course you get the feedback email from the content of today and also from Tuesday and the next days. See you. Bye-bye. Ciao.